Alright class, this is actually the notes for 5.2 day 1. Let me scroll up real quick. It says 5.2 day 1. We're skipping the review though, and we're going right to this definition. So if you guys want to pause your screen real quick and write this down, it is breaking down fractions into components. That's what partial fraction decomposition is. It's like, you know how when you add fractions together you got to get a common denominator and then you add the tops? Now we're trying to figure out where did that come from if we have one fraction with multiple factors in the denominator. How can we break that apart? So the two cases we're looking at are the non-repeating linear, which means each factor is its own, it doesn't repeat, versus the repeating linear. We're going to do the repeating linear in the next video. So basically when you want to, like I said, pause here if you need to finish writing, otherwise I'm going to scroll down. When you need to do this, we have a polynomial over some factors that are on the bottom. If all the factors for Q are non-repeating linear, then you can rewrite this as a constant over one of the factors, plus another constant over the other factor, and so on and so forth until you are done with all the factors on the bottom. And we're going to use that to actually solve for A and B and figure out what should be on top of those fractions. So write that down real quick. And then we're going to look at this one. It says write the partial fraction decomposition of x over x squared minus 5x plus 6. First thing you need to do, if it's not factored for you, you have to factor it. And hopefully you guys realize that that is x minus 3 and x minus 2. Okay? Now because both of those are linear factors, then you can, and they're non-repeating, we can rewrite this as a over x minus 3 plus b over x minus 2. Alright, so that's the first step, is setting these up. Factor and then break them down into your factors with a and b on top, and c and d if you have more. Next, we want to solve this. So we want to multiply everything by what the LCD is. So notice that the LCD is x minus 3 and x minus 2. If I multiply this chunk to all three of these things, let's just pretend I have this here, here, and here. Well, I'll just say that for that one. I'm multiplying the tops only. Do you guys see that? Because I multiplied the tops, all of the things will cancel with the x piece, and I'm just left with x for this left side of the equation. By the way, we're not looking at the original problem anymore. We're looking at the factored and then our breakdown. For this piece, for a, the x minus 3's will cancel out. So I have a times x minus 2. And for b, the x minus 2's will cancel out. So I'm left with b times x minus 3. So this is our setup that we're going to have to solve for a and b. Now, we have a lot of letters here, but we can choose the x values to use to help us solve. And what you want to do is figure out what x values will make these pieces 0 so we lose one of the letters. So if you notice, if I let x equal 2, that'll help one of them. And if I let x equal 3, that'll be the other help. It'll make this 0. So if I let x equal 2, that means I'm putting a 2 in everywhere I see an x. So this becomes 2 equals a times 2 minus 2 is 0, so that goes away, plus b times 2 minus 3. And now you can solve for b. 2 is equal to negative 1b. B is equal to negative 2. Okay? Now we do the same thing for 3. We rewrite the whole thing. 3 is equal to a times 3 minus 2 plus b times 3 minus 3. Well, that's gone. So we get 3 is equal to a. 3 minus 2 is 1a. So we have it. So now if you write this, that's not the final answer. You need to write it in your partial fractions. So go back to the top. Notice that at the top I have the a part over x minus 3. So 3 will end up over x minus 3 plus b, which is negative 2 over x minus 2. And that would be our final answer. Now, some of you guys might be thinking, well, what if I put a over the x minus 2 and b over the x minus 3 when I began? It doesn't matter. If you did that, then your a would have been negative 2 and your b would have been 3, and you'd still have 3 over this and 2 over that. Okay? Alright, let's do one more. Call it a day. Same thing, we have to do partial fraction decomposition of this thing here. Now again, first step is always factor. Can't factor the top. The bottom is y plus 2, y minus 1. I have two factors on the bottom, so I'm going to need an a and a b. I'll do y plus 2 for a, and b is going to be a y minus 1. So that is our setup. That's like our breakdown. Now we're going to multiply the whole equation again by the common factor, the least common factor, y plus 2 and y minus 1. When I multiply each three of these things, the 8y minus 7, or I should say it's plus 7, is left by itself. A, the y plus 2 cancels, so you're left with y minus 1. And b, the y minus 1s will cancel, so you're left with the y plus 2. So here's our new equation again that we're going to be using to figure out what a and b are. So the next step, remember, is to figure out, well, what should I pick for y so that I can cancel out my letters? Well, you can pick 1 and negative 2. So when y equals 1 and y equals negative 2. So when y equals 1, you put a 1 in wherever you see a y. That's including the one on the left side with the 8 and the 7. Equals a times 1 minus 1 plus b times 1 plus 2. This side is 15. A's go away. We get 3b. I get b is equal to 5. Now I have this, where I'm doing negative 2. I put the negative 2 in on the left side and the right side. The b's will go away. I get negative 16 plus 7, which is negative 9, is equal to negative 3a. So I get a equals 3. So again, the last step is go back to your top and look. Okay, a was over the y plus 2 piece. B was over the y minus 1. So a is over the y plus 2, so I get 3 over y plus 2. Excuse me. And then, I can't talk right now. And then b over the y minus 1. Okay. Now just a quick note for your homework. You can get fractions for a and b, and that's okay. Just put the fraction on top and call it a day. So for some reason, if we had 1/2 is equal to a, you'd put 1/2 over y plus 2, or whatever it is. Okay? You can also get fractions for the values you have to test, like we used 1 and negative 2. Sometimes to make it 0, you need a fraction. So don't worry about that on your homework. It is okay. And that's it. I will see you guys on the flip side.